All right, morning class, morning guys, how you doing?
Morning, sir.
Morning, sir.
Morning.
We're good.
I'm expecting about like 26 delegates. I don't know what's happening now, or they're still joining, or they will join later, or what's happening. Let me just send them a message and find out what's happening. I got my son here next to me, so you're gonna hear him a lot, like making some noise. He's also an aspiring presenter, so he wants to be a facilitator soon. So you're gonna hear him making some noises on the side. Sorry about that.
Okay, sir.
All right.
Announce. Oh, alam.
Okay, Fusi, we can hear you today. Finally, you managed to open your mic. Okay, guys. So I think we can start now, right? Most people are now joining. So today the class is going to be 1 hour. Or so what we just want to do today is go through the material, and then we're gonna do the practicals on the GNS3 software, which is like a network simulating tool that we're going to use so to prepare or to practice all the skills that we're going to learn in class. So this is Cisco CCNA, or you can use this knowledge to write any exam, which can be A plus, CompTIA Network Plus, Cisco CCNA, or Huawei HCNA. So this knowledge, you can use it, as I said yesterday, that it can be used on different qualifications, on different industry certificates, right? So yesterday we spoke about the LAN, the local area network, right? This is our local area network. And then on this side, we have another local area network, right? And then we say the example that we gave was like the branch that we have here, which is advanced assessment. And then we said, now we have computers in this side, and then we have someone else, any user from this network. So, okay, the terms that you're going to hear a lot in a network, right? Or in any organization that you're going to work for is that the people that we support in our network, they're going to be called users, right? So anyone who's not part of the IT department, we're going to call them a user in any network, that in any organization that you're going to work for. So when you hear people saying users, just know that they're talking about the people or the employees or the people that are not part of the IT department. So anytime I say a user, just know that we're talking about the people that we support in any organization or in any network. So let's say you're working for advanced assessment, you are part of the IT department. When we're talking about users, when saying users, so we're talking about the people that we support at advanced assessment. Basically, that's it when we're saying users, right? So don't be confused or don't feel like, okay, now what is it this that they're talking about when they're saying users? Users is just the people that we support in any network. Okay. As I said, that I got my son here with me. He's the one who also making some noise on the side. Please, sorry about that. He wants to facilitate, so sorry. Okay, so now we have a LAN on the side, right? We have a local area network. And then we have looked at the devices. We said this is an end device. This computer there is an end device, and then that's an end device, right? And then we said this is a server. We looked at the different terms that are going to be used in an organization. So once you are part of the IT department, you need to understand the jargons or the terms that they use for anything that they're talking about in any environment, right? So right, and then the router, we say the other name for a router is the gateway. So a gateway, it's a router that is the one that takes you out of your own network to other networks. For example, let's say now you are on this LAN, right? And then we have this user working on this LAN, and then this user wants to communicate with someone else on this other LAN. So the only device that will be able to take them out of this network to the other network is the router. So the router, we call it a gateway, right? A gateway. So meaning that it takes you from your own network to the other network. But the gateway, the term gateway, I've heard some of the companies or organizations calling the gateway, calling the firewall a gateway, or calling maybe anything that controls access a gateway. But in network engineering, the gateway we call the router a gateway. So if anyone says a gateway, most of the times they are referring to the router, right? So we said we have this envelope, which is a packet. We said when we're talking about a layer 3, we're going to break it down. What does it mean, a layer 3? So this is the guy here, the user wants to communicate with someone else on this side. And then this is their email. We call it a packet. And then when the packet moves from this computer, it goes to the switch. We said a switch is the one, or it's a device that interconnects all of the devices that we have in our network, right? So that's the role of a switch. And then now this message will reach the switch, and then from the switch, it will go straight to what? To the router, or sometimes it does what we call a broadcast message, but I don't want to talk about the broadcast messages for now. The broadcast message, okay, let me break it down now. So a broadcast message is a message that is maybe coming from one device, and then it's going to all the devices that are connected to this message. So we have different messages that we going to talk about when it comes to networking, right? The broadcast message is a message that is sent out to all the devices on our network. So all the devices that are connected to this network, they will hear the broadcast message. So what do I mean by that? So let's say this guy wants to communicate, wants to send a message, right? The first message usually becomes a broadcast message, gets to the switch broadcasts looking for the destination, right? Let's say this guy wants to communicate with the router, and then the message will go to the switch will broadcast the message, meaning that all the devices in this network will receive the message. And then when the broadcast message gets to the router, what it does is it blocks, we say it discards or it blocks a broadcast message. It doesn't allow a broadcast message to go to the internet or to other lands, right? I hope that part makes sense of what a broadcast message is, right? So we have different types of messages. So a broadcast message, we said it is the message coming from one device and then gets to the switch and then get broadcasted to all of the devices that are connected. So if the message is directed for the router and then this server receives that message, he will check what the packet, the message, right? The packet, and then see it, okay, is it addressed to him based on the IP address? We're going to talk about the IP addresses, what an IP address is, and then on that part. So the packet, the message, when it's coming from this user going to the router, it is given an IP address. It is assigned an IP address. The packet is an IP address. So all these computers will receive the broadcast message, but because the IP address, it doesn't match the IP address that they have. So because guys, yes, I'm sharing my screen. Can you see my screen? Sorry. Can you see my? You can't.
No.
Wait a minute. So you can't see my slide, the one that says end devices.
We see it. I see it.
Yeah. So the presentation, I'm just pointing on the. So now, but you can see my R, right?
No.
You can't see my case. Wow. All right. That's why I need another tool. Okay, but on the first line, you can see that we have how many people there? We have 2 people on the first line, right? On the left side, right? You can see that.
Yes.
We have 2 users, right? So So now my example is that let's say now that user, the first user there at the top, when they want to send a message to anyone else from the other networks, right? So what happens is the message has to go to the router, and then the router will check that the message is directed to who. So for example, we said this guy, this first user wants to communicate with, okay, let me draw this. I can draw something. I'm not sure if you can see my drawing.
Can't see.
Okay, I'm drawing now on the screen. Can't you see that?
No.
No. All right, let me do this. Let me open something else. I have another tool I can use for drawing. Let's hope my drawing will be better. All right, I think I have another tool here. I just want to share the screen so that you can see what exactly I'm talking about. Let me try to share my screen. All right, my thing is not working fine. All right, I just want to share my screen now quickly. Let me see if I can be able to do that. Okay, I have an Autodesk now. Can you see my Autodesk?
Yes.
All right, so let's say this is a user there, and then we have another user there. So that was the, I'm trying to illustrate what we had there, and then we had a switch somewhere here, right? And then we have another computer down here at the bottom. I don't know what about my drawings, right? And then at the top there, we have another computer. And then at the top here, we have a server, right? We had a server, a big server there. So this is the first LAN, right? And then down here, there was a router, right? The switch connects to a router. So that's a switch there. And then we have a router there. And then this router is connected to different, okay. But I'm not interested on the other network here. Okay, there was another network on the side here, which is another LAN, right? So now we say this computer, right? We have computer A, and then we have computer B, and then C. Okay, there are people trying to join. Let me see if I can admit all of them. All right. Okay, computer A, B, C, and then we have D there. So now, let's say now we're breaking down what is a broadcast message, right? A broadcast message. Let's say B, broadcast message. What is it? What is it used for? So for example, this is our LAN, right? And then we say now, if computer A, for the first time, when he wants to communicate with the router, what happens is computer A sends the message to the switch. Remember we said a switch is a device that interconnects all of the devices that we have in our network. So all of these devices are directly connected to the switch. So computer A, when he wants to communicate with, let's say maybe he wants to communicate with the router, the message goes to the switch. And then the switch, because he doesn't know the destination or where exactly is computer or where exactly is the router, what he does for the first message, he receives that message coming from computer A, and then he broadcasts the message. The reason why the switch is broadcasting the message is because he's looking for the router. He doesn't know where the router resides. He doesn't know on which interface is the router. So these lines, we call them interfaces, right? You're going to see that when we're doing GNS3 or packet tracer, when we explaining what is an interface and stuff like that. So, but for now, just know that these lines are an interface. So the first message coming from computer A, and then computer A wants to communicate with the router, we're saying that message becomes a broadcast. Why is it a broadcast? Because a switch creates what we call a table. a MAC table, right? MAC table, MAC, a MAC table. Okay, so MAC table, all right, I'm trying to write here, MAC table, right? It's a table. A table consists of the IP address and then the interface, right? No, not the IP, the MAC address. It's the MAC address here and then the interface. So now computer A, let's start again. We're saying now computer A wants to communicate with the router, right? And then we say that message goes to the switch. The switch receives, and then the switch will check now the MAC table, right? Like a map, right? Wants to see it, okay, do I know where the router is? If the switch doesn't know where the router is, on the layer 2, what happens is the switch will broadcast that message. Right? The switch receives the message and then becomes a broadcast message. A broadcast message is a message that goes out to all of the devices that are connected on this network. So we're saying now, this computer D, he has an IP address or in the MAC address. On this layer, we talk about MAC addresses, right? He has a MAC address and then the interface. This one also has his own MAC address and then this one is his own MAC address. So they look at the MAC address, right, and try to see, okay, is the packet addressed to him? If the packet is not addressed to him based on the MAC address, this computer will discard, will ignore the message, and then only the router will respond with the message, right? Because it matches. It's for example, like when we're in class like this, right? And then how many people are connected to this meeting? I think now on my side, I see about like, is it 15 people that are connected to the meeting? And then I call Gabriela, right? So not everyone in the meeting is going to respond, but all of you, you heard me talking, saying what, Gabriela, right? So that's a broadcast message. Everyone, every computer connected to that network, they heard the message, they listen or they heard the message, but nobody's going to respond. No computer is going, only the computer that is directed to is going to respond with that message. For example, I say Kumutu, right? Rose heard that message, Pindile heard that message, Amanda heard that message, but Amanda is not going to respond because the message is not directed to her. She is not Humuso, right? Humuso is the one who's going to respond because the message is directed to her. Similar with the concept that we have in the switches. All of these guys, all of these devices are given something called a MAC address and then IP addresses. But on this layer 2, we are only focusing on what? On the MAC addresses. So they will look at the packet and see, okay, is it addressed to me based on the MAC address, right? And then I say, okay, no, it's not addressed to me. Look at the MAC address and look at the IP address and says, okay, no, it's not addressed to me based on what? On the IP address. Because all of these now, they might have IP addresses. And then they discard the packet, they ignore the message. With the same scenario whereby the example that I gave, that I'll call Humuto, right? And then only Humuto is supposed to respond, but all of you, you heard the message, you heard me calling here, but you're not responding because the message is not directed to you. So that's a broadcast message. Does the broadcast message make sense?
Yes, sir.
Yes, sir.
Okay, in your own words, can I have someone else who can explain what they heard so far with the broadcast message? What does that mean? Rose?
Sir?
You want to explain what you heard in your own understanding about the broadcast? I just want to find out if it did like make sense or I confused you there.
Yeah, I can say a broadcast message is the message that goes to all the computers that are connected. Maybe, for example, I can say, let's say at my work, when they send email, all of us will receive the email. But if the invoice does not belong to you, you're not going to focus on that email. The person whom that invoice belongs to is the one who's going to respond to that email. I think it's the way I understood it.
Thank you. That's why I wanted an illustration, a different illustration from someone else. Like the way you're explaining it, like I think now most people understand it, right? Like you gave like a real scenario, a real example that we usually see in a work environment, right? So only the people that are directed, the message is directed to, are going to respond. But it doesn't mean that other people that didn't receive the message, they all received the message. It's just because the reason why they're not responding is just that they were CC'd, right? It's not directed to them, so they're not responding. So that's a broadcast message. That's what exactly happens on this network, right? So we have a switch here. So what we're talking about now, it happens on something called a layer 2. this is layer 2, right? Where the computers deal with them. Right? So let's say you have assigned IP addresses to all of these devices. So we say it now, the switch now, let's say computer A sends a message, the example that I gave, right? Computer A sends a message to the router. We said these guys are interconnected using a switch. So the message goes to the switch. The switch says, okay, sorry, it checks the make table, right? It says, okay, what do I have on my make table? It says, okay, my make table is still empty. There's nothing on my make table. So I have to broadcast this message, right? And then the switch now will broadcast the message. And then these guys, they won't respond because the message is not directed to them. The example that Rose gave, right? So they will just ignore the message. They will ignore the message. And then on this side now, the router, because the message is directed to him. How does he know that the message is directed to him? All these computers in our network, they're given a unique IP address, right? And then they also have a MAC address. So we have these two things. A MAC address is an IP, a MAC address is an address that comes embedded on the device, right? Let's say the manufacturer, Samsung, when they're manufacturing a phone, they're manufacturing a laptop, they put a MAC address. So the MAC address is a 48-bit address, which shows that who manufactured the device and then what's the device number, right? So the MAC address, it has that MAC address, it shows you who is the manufacturer of your phone, right? And then also on that page that Samsung manufactured those laptops, or which that year that Samsung manufactured those laptops, what number was that device on the page, on the page, right? So that's a MAC address. It comes embedded on the device. So every device that connects to the network, it comes in with the MAC address, right? It's a 48-bit address. And then the second one now is the IP address, right? The IP address is what is assigned to computers. The IP address is more like a home address, right? So back in the day when you wanted to send a letter to a friend, the first thing that we needed to know was the home address of that person, right? And then we write a letter, and then outside we address it to that number. So we take it to the post office take the letter, and then they drop it there. So that's the IP address. When it comes to computers here, the home address of the houses that we have on this scenario is similar to the IP addresses. So each and every computer that connects to the network or the internet, it must have an IP address, right? Does that part make sense? The MAC address and the IP addresses?
Yes, it does.
Okay, so we have the, okay, the MAC address, and then we said the MAC address is the address that comes in embedded. So now, okay, the switch, now the first communication, we said it was a broadcast, right? So this computer, come on now. Admit, all right. All right, so now computer A wants to communicate with the router, and then we said that first message was a broadcast message, right? The router broadcasted the message to every device, and then all the devices, these other devices, they didn't respond. They discarded the message, they ignored the message. But the router will respond back to the switch and says, okay, hi, sorry, I am this IP address. Maybe the IP address is 192, says, okay, the message is directed to me, and then sends it back to the switch, trying to respond to computer A. So on that part, the switch, because computer A communicated with the switch will learn the MAC address and the interface of this computer, right? And then he will write it down. So write down, let's say maybe the MAC address is A, and then the interface maybe is gig 0/1. So he writes it down. And then now when the switch, when the router responds to the switch, is trying to respond to this computer, the switch will receive that, and then the switch will write down what the MAC address of the router, and then maybe the router, let's write R there for the router, and then the interface, maybe it's a gig 0/ maybe it's on number 2 now, right? So now the next time, let's say now this router let's say now the router wants to communicate with the computer A, wants to send a message. Now, if the switch has recorded the exact location of the computer or any device in the network, it doesn't broadcast the message anymore, right? It becomes what we call a unicast message. So a unicast message, unicast. Right? So Basically, now we have what we call, we said we have what, we have a broadcast, right? A broadcast message is a message that goes back, that goes to all of the devices. So the only reason why a switch is broadcasting a message is just because on the MAC table here, the switch doesn't have that information, right? That's the only reason why the switch will broadcast a message. But once it lands, let's say all these devices now have already all communicated. Let's say this computer D is communicated and then the switch has learned all that information. Then if it has the information down here on the MAC table, there's no need for a switch to broadcast. It does what we call a unicast message. A unicast message is a message that is going to one-to-one. So that means if computer A wants to communicate with computer C, the message goes to the switch and then the switch doesn't broadcast. It's a unicast, goes straight to computer C. So all of these computers that didn't hear that message, they don't hear the message, of which now, because it's a unicast. So a unicast is a one-to-one communication where computer A directly communicates with computer C, and then the switch doesn't broadcast that message, right? Does that part make sense?
Yes.
Do you guys understand the concept of this?
Yes.
So now let me do this, right? Can I be able to delete this? I don't know how to use this thing now. Okay, let me say file. Let me say, let's say new, or I can just come here. I want to use a brush. Brushes. Where is the eraser now? There must be a tool to erase this. Okay, I just want to do something. Okay, so we said we have a broadcast message, right? That was the first message. And then the second message is a unicast. And then the last message with is a multicast. It's a multicast, right? A multicast message. So that's the message that we have. So we have three different types of messages. So when you're doing networking, these are the type of messages that you're going to see a lot, especially when you're doing dealing with the routers, the switches, right, or any computer in the network. So we said the broadcast is the message that goes to all of the devices that are connected to your network, right? And then the unicast is a message that is kind of directed to one device, and then it goes straight to that device, and then the device will respond back with that information. And then the multicast now. Okay, can you take a wild case? What is a multicast? What do you think is a multicast message? Anyone wants to try? So we say the broadcast is a message that goes to every device that is connected on the network. And then a unicast, we say it's a one-to-one communication. What do you think is a multicast communication?
Hello.
What do you think? Yeah, Litabo?
I think it's maybe.
Your volume is a bit low, Litabo. I can't hear you on my side. Or is it me here? Let me check. Yeah, you can. You're saying?
Saying that
Can you guys hear Litabo, or it's just me on my side?
We can't hear you.
No, we can't hear you.
Litabo?
Jose, can I try?
Yeah.
I think multicast can be one to many, one person can do things, or in a group.
One person to many.
Yeah.
Okay.
Or maybe in a group. A group
Thank
can
you. That's the word I was looking for, right? That's the part I'm looking for. So a multicast, right? Basically, let me go back to my. So can you see my screen, right? My drawing here, right? You can see it.
Yes.
Okay, so basically what Rose said, right? I said a multicast. So we have all these devices here. Let's say these are routers now. So a multicast is a message maybe coming from this device to a selected group of devices in the network. So we might be excluding maybe one device out of these. Let's say we have maybe, how many are they? 2, 4, 5. And then this one only chooses to communicate with what? Only 3 devices. So multicast is just a message from one device to a chosen group in your network. So we might be connected to all of these devices. All of them are connected, but he only chooses to communicate with these. Only chooses maybe 2. I want to communicate with these 2 only. So that's a multicast. So the multicast, we're going to see this message a lot when it comes to routers, right? Protocols that use multicast a lot. So they're only going to be relying on the multicast type of messages, right? So that's it. So now I just want to switch back to, okay, before I go there, let me see if I can clear this. So here's my computer. Here's my another computer there, and then my other computer there, and then this one in the middle here. It's a switch, right? So I'm using a star topology. I'm using a star topology, and then another device there. So let's say now, okay, this is computer. Let's make it A, and then let's make this one a B, make that one a C, and then make that one a D. Let's say now, this is the first time you just plugged in your switch, right? And then computer A wants to communicate with computer D. What type of message that computer C is going to use now? Is it going to use a broadcast message? Is it going to use a unicast message, a multicast message? So this is just a new switch. You just plugged in the switch. And then computer A now wants to communicate with computer D. So I'm saying the first message, is it going to be a broadcast, unicast, or a multicast message?
Unicast.
Huh? A multicast.
No.
Why? Support your answer. Ellen, is that you? You're saying a multicast?
No. No, I said a unicast because I think it's directly from B to D.
Directly from B to D. It's a multicast.
No, uni.
Right? Anyone wants to try? And then say it's a multicast message. So the first message said it's going to be a multicast. Letabo?
Can you hear me, sir?
The Tabo? Sure, there's something wrong with your mic, Letabo. I'm not, because I can't hear you from my end. Okay, it's just his network. All right. So anyone wants to try? What type of message? So this is the first time, right? We just plugged in the switch, and then we're saying this is a brand new switch, and then we've plugged in the switch there, and the computer A now, this is the first message that is sent into computer D. My question is, will the switch broadcast this message, or it will be a unicast, or it's going to be a multicast message? Ellen says it's a multicast message. What do you think? Josias?
I think I can say a multicast because computer A it chooses whoever you want to communicate with. So now you choose D. If you want to choose maybe 2, you can choose D and C, or D. It's up to computer A to choose. So now you choose A. So that is why I support my answer as I think my answer is multicast.
Multicast. All right.
So can you hear me?
Yeah, I can hear you. Yeah, let's have.
I think it will be broadcast. I didn't hear the definition of multicast, but I'm going with broadcast.
Broadcast. All right, so let me break it down again. Okay, now let me take us back a while back before we had the switches, right? So back in the day, we had a device called a hub, right? Let me remove this. Let me change this to a hub, right? So the hub now, it had no intelligence. It wasn't able to learn any networks. So every time a hub received a message, what it did was it will, every time computer A wants to communicate with computer D, it was going to be a broadcast. Computer C wants to communicate with any computer. So any communications here, when using a hub, it was a broadcast. So the problem with the broadcast message is that it slows down your bandwidth, right? Because one computer now is communicating and then the message goes to every device, which kind of like slows down your network. That's why now most companies, they moved to a device which is called a switch. A switch is a more intelligent device. A switch is a more intelligent device. Sorry about that. A switch is a more intelligent device. What happens is it learns MAC addresses. So the minute a switch, let's remove this now. We said a hub. The problem with the hub, any communication that's coming from any of these devices, it doesn't learn any MAC addresses. It doesn't learn the interface, right? So here's the concept, right? The reason why these devices use a broadcast message is, for example, let's say now we have, let's say this is Litabo, right? He wants to communicate, he wants to talk to, maybe let's say this is Komuto down there on C. And then this is the person at the reception, right? Now Litabo, because he doesn't know, okay, that example won't work. Okay, let me not go there. It will kind of confuse you. All right, so we said a hub, what it does is it receives a message, and then it broadcasts to every device. So it doesn't learn any MAC addresses. That's the difference between a hub and a switch. So now let's take out the hub and then bring in, let's say now this is a switch. Okay, back to a switch now. A switch now, we said it has intelligence, right? So if computer A, for the first time now, we said this one here is a MAC table. You remember the MAC table that I spoke about, right? We said on this part, it keeps what we call the MAC addresses, right? And then maybe on the other side, it keeps the interface. We said computer A wants to communicate with computer D. It's the first message, right? So that means the switch doesn't know where exactly is computer D. But the only thing that these computers know is the IP addresses. Let's say all of them are assigned an IP address 192. Maybe this one is a .19. This one maybe is a .29. This one is a .30. So the first message is coming from computer A, and then computer A, maybe let's make him a 31. This is an IP address. Don't worry about IP addresses. We're going to break them down. But now we're just focusing on this concept. So computer A, what happens to computer A? Sends a message to the switch. The switch, we said it is intelligence, right? It will receive a message coming from computer A, and then it puts that information on a MAC table and then writes down. So that means now the first message is a broadcast because the switch doesn't know where exactly is computer D. So the reason why the switch is broadcasting is because the MAC address or the MAC table is empty, right? The minute he receives a message from this computer A, he writes down the MAC address of computer A. Let's say his MAC address is A, and then the interface is gig, maybe, let's say gig/1, right? Don't worry about the interfaces. We're going to break it down when we're using packet tracer and GNS3. Okay, so he has learned one, right? And then now he communicates, the switch says, okay, I have learned your MAC address, right? I know where you are, but now I don't know where computer D is. So it's going to be a broadcast message so that the correct device is going to respond. The minute the correct device responds, he responds with his own MAC address and then his own IP address. So the switch now will learn the MAC address of D and then the interface of D. Say gig/2. Right? So now, anytime when the switch knows where the computer is, it becomes a unicast message. It doesn't have to broadcast a message because the switch already has information about what? Computer D, right? But now, let's say computer B wants to start a new message communicating with computer C. What do you think is going to happen? Will it be a broadcast message, a unicast message, or a multicast message? Now, computer B wants to communicate with computer C. So we have computer B wants to communicate with computer C, right? What do you think is it going to be? Is it going to be a unicast? The switch, for example, we're looking at the switch. Is the switch going to broadcast the message, or is the switch going to do a multicast or a unicast? George?
It's a unicast, maybe because it's a direct message from computer A to computer D, I think. You said
Yeah.
D?
Yeah. So, okay.
Yeah, I think it's a unicast.
I'm happy that you guys have mastered that concept, right? You know what a unicast message is, and then what a broadcast message is, and then what a multicast message is. But now we have moved from the broadcast and that. Now we're looking at the concept of the switch now, the behavior of the switch. How is the switch going to behave? Is it going to broadcast this message? Litabo.
So question, has it learned the routing table yet?
All right, that's the good question. That's the first one, right? So we're saying now the switch, before it broadcasts a message, it checks the make table, right? Says, okay, computer B, I didn't have your information, right? So it adds that information because computer B is communicating, wants to communicate with C. So now the switch will learn the MAC address of computer B, and then also learn what? The interface, maybe it's a gig what? Gig number 3. But now the switch doesn't know where is computer C. So what is he going to do? What's the behavior of the switch now? If he doesn't know where the computer is, or doesn't know the destination of the computer, where exactly is the computer that it wants to communicate with? Let me try. I know you want to answer that one. Ellen, let me try Ellen.
It's gonna broadcast the message so that the original one can find it. So
Right.
it's gonna do a broadcast.
Thank you. Right. So now the behavior of the switch, right? It says, okay, you want to communicate with this computer, computer .19, right? And then the message will, the switch says, okay, checks the make table, says, okay, I don't have C here on my make table, right? So I don't know where exactly is. It might be connected to my interface, but I don't know where is it located. So the best thing to do is to broadcast the message. Then he broadcasts the message. All the devices will receive the message. Computer A will say, okay, no, I'm not a 19.19. I'm not a .29. And then, okay, computer C will say, I'm a 19, right? So you want to communicate with me. And then he responds. The minute he responds, the switch learns that MAC address and then records it now. And then says, okay, what interface are you coming from? Says, okay, you reside in that interface, which is maybe gig slash maybe number 4. So the switch now, the minute it has recorded all of this information, there is no more broadcast messages, because it knows if now, let's say, okay, let me ask this one now. Let's say, well, let me see who is it going to. Okay, let's say now computer C wants to communicate with computer D. What's the behavior of the switch? What exactly the switch is going to do? What exactly the switch going to do? Will it broadcast the message? We have computer C trying to communicate with computer D. What exactly the switch is going to do? Will it be a broadcast, unicast, multicast? Anyone wants to try? Methu. You are quiet, Methu. Are you there?
Hello, can you hear me?
Yeah, I can hear you now.
I think it'll be, I don't know, a multicast.
Multicast.
Yeah.
Okay. The table?
It's gonna be a broadcast.
A broadcast message. Why?
Yes.
Why?
Because it hasn't learned the MAC addresses yet, so it has to broadcast the message.
But check the make table now. Check the make table.
Oh, okay. So it's sending from one computer to another.
Yeah, so now it's going to be a unicast message, right? Because the switch, what it does, if it receives a message from computer C, remember the switch will receive the message from computer C and then checks and says, okay, coming from computer C, and then checks the make table. The most important thing is the make table. Checks and says, okay, I learned this interface, I learned the MAC address of computer C when computer B was communicating with computer C. So now I know where exactly computer C is, right? And then now computer C wants to communicate with computer D, but computer C and computer D, they haven't communicated before, right? They haven't sent any messages, but the switch now will check the MAC table and says, okay, let me see if I recorded the MAC address or the interface of computer D. And then when he checks this MAC table, you will see that on this part, he has the MAC address and the interface of computer D because he recorded that the time computer A communicated with computer D. Right? Even though this is the first message from computer C to computer D, because there was a communication before, so that means the switch managed to record that information. So you will check and see if he has the information of computer D. And then when he finds that, okay, I recorded computer D when computer A was communicating with computer D, it's no longer a broadcast message because the switch now knows where this computer resides. Does that make sense?
Yes.
Okay, let's play a game now. Let me check here. Let me see if I can do this again. Okay, this is a switch. And then this is my computer there. And then there's my other computer there. And then my other computer. So these are the basics of computers. Like before you even start with the packet tracer, these are the concepts that you need to understand what happens on the background, right? When the computer communicates. Let's say this is A, this is computer B, computer C, and then computer D. And then this is a switch. And then when the switch is new, right, most of the times the MAC tape is empty. So this is the MAC tape of the switch, right? And then the MAC tape is new, the switch is new, and then the MAC tape is empty. So computer A, well, this is a new switch, this is a new network, right? It's a brand new network, and there's a brand new switch there. Computer A wants to communicate with computer C. What is the switch going to do? Is that going to be a broadcast message or is going to be a unicast or multicast message? Matthew? Matthew?
Okay.
It's
I
going to
think
be
I think I
unicast
get it
because it's a
now.
direct message from point A to C.
I think I get it now.
All right.
When the switch is new, it has to broadcast,
Yeah.
and then when it does its first broadcast, it's going to communicate with all the computers in the network, and then from there, it's going to learn all the addresses, and then like so the next time there needs to be a unicast message, it will unicast because it has learned all the addresses. But then when it's a new switch and it hasn't learned all the addresses, then it will do a broadcast message for the first time.
All right, that's the concept, right? So first I broke down the messages type, right? We said a broadcast, it goes to everyone. But now the behavior of the switch, what we're now going through is the behavior of the switch. That's what Matt is going through and I was explaining, right? This is the brand new switch. So the first thing the switch does is it looks at the MAC table, right? We're saying computer A wants to communicate with computer C. Computer C so let's say computer A wants to communicate with computer C. What it does is it checks the MAC table. What exactly does it have on the MAC table? It says, okay, I don't know where computer C is. So the best thing to do is, or to learn this network, or to learn the MAC addresses of all these devices, or where exactly they are, is to broadcast. So the first message now, it becomes, computer A communicates with computer C, it goes to everyone, right? Computer D will receive the message but ignores it. Computer B will receive the message, ignores it. And then computer C will says, okay, it is addressed to me. So now, on the first message, the switch has learned how many network, how many interfaces, how many MAC addresses. This one of computer A, and then writes it down. Remember, computer D, it doesn't respond. It doesn't respond on this part. Let's say if computer A wants to communicate with computer C, and then the switch broadcast to all the devices, these two devices aren't going to respond. They ignore the message. So that means the switch is not going to learn anything, right? Because these two guys, they didn't respond. But computer C will respond with the message saying, okay, you want to communicate with me, I am on this interface. The minute computer C receives that, computer C responds, the switch writes it down, says, okay, this is C. And then the interface is gig what? A map is gig 1, right? And then computer A is the one who started the conversation and then says, okay, computer A is there on maybe on gig what? Interface maybe 2. And then it's recorded. Now, let's say computer B wants to communicate with computer A, what do you think the switch is going to do? What's the behavior of the switch? Computer B wants to communicate with computer A. Anyone wants to try that one? So we say the switch, before it makes any decision, what it does, it has to check the make table first. So we're saying now we are on this computer, let's say we are on this computer, computer B now wants to communicate with computer A. So what type of a message, what exactly the switch is going to do? Will it broadcast the message? Will it unicast or multicast? Josias?
I think it will unicast, because in this case now the switch, they know the address of the computer A, so it will just record the address of it will check the address of the computer B, but send the message straight to computer A, because it knows the address of computer A is. So I'll go for unicast.
Right, thank you. At least I'm making progress. Now I can close this topic and move to the next slide, right? So here's the thing. What you said, first thing, the behavior of a switch. We're saying message is coming from computer B, but the switch hasn't recorded that message, so he will record the message, the MAC address of computer B, and then the interface maybe is gig 03. But now the switch says, okay, you want to communicate with computer A. Let me check on my MAC address if I know where exactly computer A is. It says, okay, I got computer A because computer A once communicated with another computer, and then I recorded that information, right? So now it's no longer a broadcast message. It's what? It's a unicast, as Josias has said, right? Because why is it a unicast? Because I already know, the switch already knows where the computer is. Makes sense? So it's a unicast message. So the switch will decide based on what it has on the MAC table, right? So let me close this and go back to the slide. I hope, okay, before I move any further, before I close this, anyone with questions to regards to this? Anyone who has questions? So this is the behavior, it happens on layer 2, right? So when computers communicate on layer 2, they must know the MAC addresses and the interfaces, like I will show you. Also, the computers, they record they have what we call the MAC table. They create their own MAC table. The switch also creates the MAC table. And then the other thing is this MAC table, it is cleared every 5 minutes, right? Because it happens that sometimes maybe someone else comes and then removes this computer C from this interface and then plugs it on a different interface. So every 5 minutes, this MAC table is refreshed, and then the switch will start afresh again from goes through the same process. So that's what happens on the networking side of things, right? So these are the questions that when you're doing CCNA or computer, what you call CompTIA N plus, these are the questions they're going to ask you. They put a diagram like this and then ask you, okay, what type of a message is it going to be? A broadcast message, and then they give you like a MAC table, and then ask you, okay, what type of a message is it going to be? A broadcast, unicast, or multicast message? So you need to know all of these things, how these devices do communicate. Right. Okay, if there are not any questions, let me switch back to my slide, right? Where is my slide? All right, let me cancel that, and then I had a slide somewhere. Okay, let me check where my slide is. So, okay, let me just go there. More windows. Where's the slide? I think this is the one. Okay, guys, can you see my slide now?
Yes, we can.
Yes.
Okay, let me just
Yes.
quickly move to where we were. I think we're somewhere. So we're somewhere here, right? So you can see this part, right? We're somewhere here. Now we say this is a LAN, so that's what happens inside the switch, right? And then now the other thing is the broadcast message. The router doesn't send the broadcast message outside of this network. So if the router receives any broadcast message, it stops it. So the broadcast message, it ends on this LAN. It can't go to other networks. So any broadcast that happens on this network, it can't go to this internet, it can't go to this other LAN, right? So a broadcast will be limited inside this, it will be contained in this network. The router will block that, or it won't send it outside the other networks, right? So we know what a router is used for in a network, right? So at home, right, if you want to set up a small network, or we call it a small office, home office network, right? So what happens is the first thing that you need to buy is a router. A router gives you access to the internet, right, or to the network. So the router now, if this computer wants to communicate, so okay, before I go ahead of myself, let me do this. Sucks. What happened now? Where was I? I can't see this part. But me. Okay, I can't find my slide. All right, I'm back on my slide. Okay, so now what do I want to say? So okay, so now let's say we cut this router. Let's say we don't have a router here. So you know, if you assign IP addresses to these computers now, all of them they have IP addresses. You know that these computers will be able to communicate, all of them, as long as they are connected to this switch and then they are all interconnected together. Even though we don't have the internet, these guys will be able to communicate with each other, right? We have created a network. But the problem is that once they want to connect to the internet, then we need a router, right? We need an ISP. We need a router to come in and then say, okay, now we have access to the internet. Without a router, these computers will be able to communicate, but they only communicate within this network. They won't be able to access the internet. And then that's why we bring in a router, and then the router will be able to play a role of being a gateway, take you out of your own network to the internet or to other LANs, right? That's the role of a router in a network. Okay, let me move to the next slide. Okay, intermediary network devices. So you will see that in our network, we have devices like a LAN, a switch, right? We spoke about a switch, and then we have a wireless router. Wireless router, basically what it does, it offers us wireless services, right? So like these days, most companies, what they do, they don't have they don't have like Ethernet networks, right? What they have mostly, all of their users, they connect to the router wirelessly, right? They don't have the Ethernet cables, they don't connect all of those. They've moved to wireless, most of their networks. So we need a wireless router to do that. And then we have a multi-layer switch. A multi-layer switch is a switch that operates in 2 layers, on a layer 2 and then also on layer 3. This switch, we call it a layer 2 switch, right? Because it only operates on one layer, which is a layer 2. Okay. And then we have a router. I've explained to you what a router is. So the difference between this wireless router and this router is just that it has wireless capabilities, right? So it can play a role of being a wireless, right? So we can connect all of our devices to the router wireless, like the home router that we have at home, right? And then this router is the one that we just plug into the switch and then gives us access to the internet using that router. Okay, at the top, the management of data as it flows through a network is also the role of an intermediary device, including, so these devices, what they do is they regenerate and retransmit data signals. So on Packet Tracer, we're going to build our own network using what we call wireless LAN controller and then the access points, right? With some of the guys, we have done that, but we will also kind of like try to go through that. So a wireless LAN controller is the one maybe that we're going to use maybe to control the access points that we have in our network. I'm sure most of you have seen maybe in any organization something on the ceiling. We've seen like a small cylinder thing or white thing on the ceiling, which most of them, they call it an access point. Some they give it a different name. So what an access point does is just that it extends the signal of the router to be able to reach other spaces in your network. Let's say you have 4 floors in your network, and then you want the router to be able to, you want the signal to reach all of those floors that we have in your network. Then we add what we call an access point. So all of these devices, we call them intermediate devices, right? So they regenerate and retransmit data signals. An access point can play that role. Maintain information about what pathways exist in the network. A router can play this role. And then also retransmit data signals. A switch can do that, right? We looked at that whereby computer A wanted to communicate with computer C, and then the message went to the switch. The switch took that message and then retransmitted to what? To computer D. So that's the role of all of these intermediate devices. And then the other point is that notify other devices of errors and communication failures, right? So we have other devices that will be responsible for that. Let's say a router can send a message called, what do you call that message? Let's say you ping another device and then there is no, the device can't communicate with other device, and then you receive a ping, a response back saying, okay, the destination device wasn't reached. So that's what it's talking about here when it says notify other devices of errors if communication failures. So the router will also play that role. If your computer is not able to reach another LAN, the router will be able to send back a message to you, say, okay, destination was unreachable, right? So this is the role that these intermediate devices play in our network. So these are Cisco devices, and then on Packet Tracer, we are going to go through all of that, and then you must be able to configure all of these devices in a network. Okay. So what else am I missing on this part? Any questions before I move to next slide? Okay, we have a firewall here, a firewall appliance. So what the role of a firewall is for access control list, right? It can create what we call access control list. So you when you building your own network, you need to specify out, okay, who has access to certain resources in your network or who has access to your network. So the firewall will play that role in terms of like blocking unauthorized access to your network. So the firewall will block, let's say, IP addresses, or block, let's say, ports, any port that is not allowed to access your network, any device that is not allowed to access any resources within your network. So the firewall will play that role of blocking or maintaining access to only the authorized devices to your network. So that's what the firewall will do in your network, right? So this multi-layer switch, it can play the role of a router and then also play a role of a switch. So it can be a router and can also be a switch, right? That's the use of a multi-layer switch. Okay. Any questions before I move to the next slide? If you want any explanation on this slide, yeah, Litabo.
Yes, I just wanted to ask, what is the difference between access point and a repeater, or is a repeater type of an access point?
So like they're kind of playing the same role, right? So the role of an access point, what we do is we build we configure our router maybe on the first floor, and then on the second floor, definitely you find that maybe your router can't reach the signal of the router can't reach the second floor. Let's say your building has maybe 5 floors, right? And then your router is on the 5th floor, but you want your network to your signals to reach other floors. So what you can do is you can create an access point, of which your question is, does the access point and the repeater plays the same role? Yes, definitely that's what they're doing, right? Because they're just repeating the signal to other areas of your premises.
Okay. And then on switches, you said some of them operate on layer 2 and 3.
Yeah, this is the
ask why
multi-layer.
layer 3?
So we're going to get to that part on the practical side of things, what exactly it means, because this one, on the layer 2, we say it only focuses on the MAC addresses, the interfaces, and then it doesn't have routing capabilities. It can't route a packet to any other networks. But this multi-layer layer switch, what it does, it can do what the router do, right? So meaning that it can take some networks, let's say, for example, we said, the example that I gave was where we had a router, we had computers and then a switch. And then I said those computers, right, if they don't have a router, they won't be able to access the internet, right? But now, if you have a multi-layer switch, then that means those computers without a router, they can access the internet if they have a multi-layer switch, because a multi-layer switch, it is the capabilities of performing or running as a router. Does that part make sense? You remember the example that I gave? I said, if those networks, if those 3 computers and then a switch, if they don't have a router, they are not able to access the internet, right? But they are able to communicate within that area because they don't have a router. But now if I remove that layer 2 switch and then I bring in that multi-layer switch, then that means I no longer need a router, because this switch can play those roles of becoming what? A router, and then a switch interconnecting all of the devices. I'm not sure if it makes sense.
Yes, it does.
Okay, if it doesn't, let me just go back to maybe try to demonstrate that. Okay, I don't have to throw it, but I can just go back. Okay, here's the part, right? You can see, let's cancel this router, right? Let's say there's no router. There's only this switch. This is a layer 2 switch, right? So we're saying now, if it's a layer 2 switch, all of these computers, right? They will be able to communicate within this area, but are not able to access the internet because this is a layer 2 switch, right? It can't route, it can't access the internet. But if it's a multi-layer switch on this part, then that means we don't need a router anymore. That multi-layer switch, it can perform the responsibility or do exactly what the router can do on this part. Does that part make sense? So we remove a router and then get a multi-layer switch. Then it acts as a switch and also as a router. So it has capabilities of working as a router. Does that answer your question, Letamo?
Yes.
Okay, all right. So these are the intermediate devices, right? So we have all of these devices. Okay, now we have something called the medium, right? I think some of you that are part of the HP group, I have already explained to you what a medium is, right? Okay, so let's do this. Sorry, my phone is ringing. I don't know why am I receiving that. Okay, so the medium now. So communication across a network is carried through a medium which allows a message to travel from source to destination. Okay, Matthew, I need a favor from you, man. Can you kind of like, okay, can you explain what a medium is to us? Is Matthew still connected? Let me see if I.
Yeah, I'm here.
Okay.
Okay, so a medium, it's like a pathway for data to move or for communication between devices in a network. So it can be Ethernet cables, it can be wireless transmission, the works.
Right? So that's the medium, right? Just a medium is any means or anything that carries data from one computer to another computer. For example, we have an Ethernet cable, right? So when I connect 2 computers together using an Ethernet cable, so that means now computer A can be able to communicate with computer B because all of them, they are directly connected together using a medium. So a medium is any means of transmitting signal from one computer to another computer or from one device to any other device, right? So we have different types of mediums that we can use when it comes to communication, right? Now, Gabriela, can you kindly explain to us what you know about a fiber cable? Because fiber cable is one of the medium that is used in the network. Gabriela, can you kindly explain what you know by, let's say, what you know about fiber cable?
So what I know is fiber cable uses high networks, which is faster and also has longer distances. It's also expensive.
All right,
That's all I
thank
know,
you.
sir.
Yeah, that's it. I thought we were going to talk about what type of signal does it use in order for it to transmit data from one side to the other side. Remember, we said some they use light, some they
Uses
use.
light.
So
So I
fiber
know
uses
fiber
light,
uses
right? So fiber uses light. So these are different types of mediums. I'm sure most of you guys have heard about the fiber optic cables, right? Fiber optic cables uses light to transmit data from one computer to another computer, right? And then what about Ethernet cables? What does it use? Ethernet cables. Mfusi, I think we explained this in class, right? I'm not sure if you still remember that part.
So
Okay,
Ethernet cables
yeah,
use electrical signals to
right,
transfer.
right. So Ethernet cables uses, okay, Gabriela, do me a favor, right? Do this. So give me the disadvantages and advantages of Ethernet cables. Remember, we spoke about what can affect Ethernet cables when you're communicating.
Yes. So the disadvantage would be that it uses electrical signals. I think that's an advantage. And it it is affected by crosstalk, so where the
Crosstalk,
signal
right?
will be lost.
All right.
And an advantage is it's faster.
It's faster than copper cables, right?
Yes, sir.
Okay. Coax, I mean, coax cables, right? Mfusi, you're about to say something? All right, so these are different mediums that we're talking about now. I'm sure most of you have seen these cables, right? So let's say you are at work, right? And then they talk about the copper cables. Most of them is the Ethernet cable. So if they say copper cable, just know that they're talking about the Ethernet cable. So the Ethernet cable, we said it uses electrical signal to transmit data from one device to another device, right? And then just because it uses electrical signals, it can be affected by something called EMI, which is electromagnetic interference. So if you, let's say you lay down your cables close to a fluorescent light, the copper the copper straight through the Ethernet cables can be affected by that, right? Because they use electrical signals. But for fiber now, if you lay down them close to any electrical appliance that, for example, we have machines in a mine. So in a mine, usually we use the if your only option is Ethernet cables, right? When you're working in a mine, because in mines we know that they usually have like the what you call these heavy machines which transmit higher signals, right? So what happens is the Ethernet cable can be affected by that, but we have two different types of Ethernet cables. We have the shielded twisted pair, and then we have the unshielded twisted pair, right? So the shielded twisted pair is the one that can protect against electrical signals. So that one, if your only option is Ethernet cable, we are in an environment whereby the only option that we have is Ethernet cables, then what you do is you go for a shielded twisted pair Ethernet cable. So Ethernet cables, there's two types. The first type is the shielded twisted pair. The second one is unshielded twisted pair. Back in the day, the shielded twisted pair was way expensive than the unshielded twisted pair. So the shielded twisted pair, it comes in with the coating that protects against EMI. EMI, we said it is an electromagnetic interference, which is what is transmitted by these electrical machines that the heavy machines, right, that uses electricity. So if you are using a shielded twisted pair, then your option will be the shielded twisted pair. All right. That's the copper straight through. What's the other problem? We spoke about attenuation. Matthew or Litabo, do you, Mfusi, the guys, HP, do you guys still remember what attenuation is when it comes to Ethernet cables?
I think it's when the signal is lost, maybe when there's no terminators.
Right, so attenuation, in short, it is so all of these cables, they have the maximum distance that you can crimp them for. For example, if you're using an Ethernet cable, we have different standards, right? We have CAT 5E, we have CAT 6E, we have CAT 7, we have all of those, right? Most of the times, the Ethernet cables, their maximum distance is 10 meters, right? Gabriela, do you still remember the maximum? Is it, oh, sorry, 100 meters, not 10 meters, right? Was it 100 meters?
So I'm not sure how many meters. I don't remember.
Letabo. Can you remind me? I forgot. Yeah. No, it can't be 10. It must be. Yeah, Letabo. Letabo, your mic is off. You want to say something? Your hand is up. All right. So now, guys, what we're doing is we're going through the different types of mediums that can be used in any environment. And then also we're looking at the disadvantages of those mediums. So that, here's the thing, right? Once you become a network engineer, right, you might find yourself maybe becoming what you call a consultant, right? The minute you become a consultant, that means you fully understand the pros and cons of all of the devices and then all of the types of topologies that you have in the network. So a consultant, you will be advising people in terms of like what type of cables or what type of devices do they need to use based on the requirements and also the environment that they are running on, right? So now, if you fully understand the disadvantages and advantages of a copper cable, then it becomes easy for you to make like a decision or informed decision because you fully understand the pros and cons of a copper cable, right? So number one, we said the copper it uses electrical signals to transmit data from one device to another device, right? And then we said the copper can be affected by something called EMI, right? Which is when you place them close to any device that transmit higher power, then it can be affected. The signal can be lost along the way, right? And then number three, we said it can be affected by something called attenuation. So we said the maximum distance for most of the copper cables is 100 meters, right? So if you crimp them, maybe let's say 200 meters, that means the signal will be lost along the way, right? So the recommended for a Cat5, the maximum distance is 100 meters. So if you crimp them to be longer than that distance, then the signal will start to lose along the way. We call it degradation or attenuation, whereby the cable start losing signals. So the signal maybe might not be able to reach the final destination in the end. So that's what we're talking about when we're saying attenuation or degradation. And then Gabriela spoke about the what you call the crosstalk. Crosstalk is a concept whereby, let's say you place maybe two cables close to each other, and then the signal that was supposed to move from one cable ends up bleeding to the next cable. So those are the problems with the copper straight through, right? And then we said, okay, if you are in an environment that has many machines that transmit a lot of higher power, then we said we have two options. We have the unshielded twisted pair, and then also we have the shielded twisted pair. The shielded twisted pair, it comes in with a coating, right, which protects against EMI. So it becomes immune to EMI. So it would all depend with the environment that you are in. I once worked in a mine. I know what are the types of machines that they use in an environment like that, of which the unshielded twisted pair copper, it won't work in that type of environment because of that. Okay, now let's move to fiber optic cables. Fiber optic cables, it has two types. Okay, the ones that I know, it has two types because you know with technology now I might say it's only two types. One is maybe they've introduced the latest one now, right? So currently today in my knowing, right, my knowledge, based on my knowledge, what I know, fiber optic cables, it has two types. It has one that we call it a single mode, right? And then also you have what you call a multi-mode. And then we said fiber uses light. So the single mode, it uses what we call the laser light, right? So currently fiber, it is the fastest cable, right? So it is the most expensive cable that is used because every time when a technology is new, it always expensive, right? Because now fiber is one of the most, it's the latest medium, right? It's expensive, that's why, because it's the newer one. And then what are the disadvantages of fiber? Okay, it's just few. The single mode, it covers longer distances, so it's not affected by attenuation, right? Because it covers longer distances. And then the reason why we say the single mode, it uses what we call laser light, all right? And then now the multi-mode, it uses not laser, it uses LED light. So the single mode is faster than the multi-mode. I think I need to draw this. Do I have, can I just switch and then try to draw it? Okay, I don't think I can be able to draw this. Let me see if I can draw this for you quickly. Just quickly draw. Let me kill that and then try to. Okay, now I'm sure you can see my. Okay, so let's say this is a fiber cable, right? And then this is single mode. This is single mode, right? SM. And then this is your fiber optic cable. This is multi-mode, right? We said number one, the single mode uses laser light, right? So the signal travels into what? In a straight line. That's why it is faster and then covers longer distances. The multi-mode now, the problem with multi-mode, we said it uses LED light. And then the way the signal travel on this line, it uses what we call, it travels like this. It keeps on bouncing off the cable, right? Off the edge of the line of the cable, right? So which shortens the distance that the multimode covers. But still, the multimode, it is faster than Ethernet cables. It's faster than the coax cable. It is faster than all of the other cables that you know. So the faster one when it comes to optic fiber is the single mode. It uses laser light, and then this one, the disadvantage, the only problem is that the signal bounces off the edge, right? So that's the only difference between these two. But all of these are fiber cables. It's just that we have two types of fiber cables. We have the single mode, we have the multi-mode. Same with the Ethernet cable. We said we have two types, which is the shielded twisted pair, and then we have the UTP, which is unshielded twisted pair. So does that make sense? Do you understand why we have these two? So we have these two types on the fiber, and then we have the two types on the shielded twisted pair. Okay, let me switch over to my slides. You can ask any questions as I try to switch over to another slide. Letaba, your hand is up. You can ask a question as I try to switch to the other side. Okay, I'm back on my slide. Okay, what do we have here? We have, I think, spoken enough of the fiber cable and then the copper and then the wireless. What do you think is the disadvantage of a wireless cable? Sorry, a wireless connection. I'm saying wireless cable as if like wireless is cable. So what do you think is the disadvantage of a wireless connection? Okay, let's start with the advantages first. Anyone who knows the advantages of the wireless cable, wireless connection? Advantages of a wireless connection? Pindile?
So,
Yeah, Gabriela?
so I think one advantage would be that it's fast, it's
fast.
portable, it's easier.
So wireless is fast, right? You can say it's fast, and then also mobile, right? It allows you to move around. Like back in the
Yes.
day, it was only Ethernet cables, right? So if you're using a computer, a laptop, or a desktop, you were only stuck to that position, right? Because of the Ethernet cables, you were not able to move because the Ethernet cable was always there, right? But now, because we have wireless, allows us to be mobile, right? You can move from one department to another department using your laptop, still connected to the internet. So those are the advantages of what? Of the wireless. But when it comes to security, right, I always tell people that wireless is not that secure, right? Because we have people that can intercept the signal and then also try to listen to whatever you are saying or whatever you're sending on that line. So wireless is not secure, but it allows, the bigger advantage is that allows us to be mobile, can move around from one department to another department, from one department to other department, and then able to communicate with other departments. Right? Okay, I think that is wireless. Okay, let me read that. Metal wires within cables uses electrical signals impulses, which is copper, uses pulses of light, right, which is fiber, and then wireless uses modulation of specific frequencies of electromagnetic waves. So those are the three major mediums that you're going to see in different organizations, right? So the other thing is okay, when we go back to maybe office, when this COVID is over, then we go back to office. We're going to go through these cables, and then you see the cable, you see Ethernet cables, you see fiber optic cables, and then how they look like and stuff like that. All right. Wow. All right, network presentations, right? So these are the icons that you're going to see on Packet Tracer. So for our learning or for our practicals, right, so that we can be able to master the concept, we're going to use a simulator, a network simulator, which is Packet Tracer and then GNS3. So these are the softwares that kind of like simulate what happens in the real world, right? So the things that you see in the real world are what we're going to go through using the Packet Tracer. So how to configure a switch, you're going to do that using Packet Tracer. How to configure a router, we're going to do that using Packet Tracer. So for other classes, maybe next week, you're going to need to have a laptop with you. But for this week, we're just going through theory. And then next week, we're going to go through different protocols. With other guys, we have covered maybe RIP, we have covered OSPF, we have covered DHCP, how to configure DHCP. So you will need a laptop to be able to understand and also maybe configure all of these protocols on any device, right? So end devices, we have IP phone, we have wireless tablet, we have all of these that we have in our network, right? So you're going to see these on Packet Tracer. These are the icons that are going to be used on the Packet Tracer. And then we have intermediate devices. We have wireless router. We have our wireless router. We have a LAN switch. We have all of these. We've looked at these. And then when it comes to network media, you're going to see all of these devices, or these interfaces, or these mediums represented like this, right? LAN media, wireless will be presented like that, and then that. So important terms to know include network interface card and NIC. So a network interface card, it is the one that allows us to maybe to gain access to the internet, maybe to plug in your Ethernet cable, or to plug in maybe your wirelessly, to connect wirelessly. Then you need a network interface card. And then a physical port, you're going to look at that physical port on a switch, on a router, on any end device. And then the interface, I've spoken about the interface. I showed you what an interface is, right, on that diagram that I showed you with regards to the MAC addresses, right? All right, let me see if I have. Okay, a topology. So the guys that are doing system support, right? You're going to receive, or you're going to see assignments that are asking you about different types of topologies. So what exactly is a topology? So a topology is just a laying down of your network. It's the design of your network, how your network looks like, right? So that's what a topology is. So it's the design of your network. So we have different types of topologies. So Letabo, can you kindly explain to us what a star topology is, and then also the advantages and disadvantages of a star topology?
A star topology, all the devices are centrally connected to the switch.
Right, and then advantages of that? So okay, let me switch to, let me try to draw that. I love drawing, even though my drawing is not that perfect, but at least it kind of like brings the concept across. Let me see. You cancel. I don't want to save this. So the star topology, you guys have seen a star topology, right? We have used, let's say that was a switch, and then, right, this is a star topology. We have a computer there, we have another computer there, we have another computer down here. So essentially what happens here, the star topology, all the devices are directly connected to the switch.
Advantages is that
Yeah. Letabo, advantages?
can I start with the disadvantages?
Sharp. So
I think first disadvantage that I can think of is that if there is a malicious hacker in the system, if he learns the router's MAC address, he can request. How can I say? He can send a ping request to devices, maybe to overload one device using other devices, or he can request it, and all the packets will be going directly to him. That's one disadvantage that I can think of.
Right.
Another one, as compared to a ring, there's only one way to get the signal to the endpoints.
Okay.
But I think that it's much faster than maybe a bus and a ring. The signal travels a shorter distance.
Okay. So let's say star topology, that's a star. And then a ring topology, let's put it up there. That's one computer, another computer, another computer, another computer there. And then we have a bus topology down here. There's a bus topology. So as I said, right, the topology is just the way you lay down your network, like the design of your network. How do you prefer your network to be like? So we just want to go through the disadvantages and advantages of those topologies so that when you are planning on designing your own network, you already know what advantages are you going to face and then what disadvantages are you going to see when it comes to that specific device, right? So when it comes to that specific type of network. So we have a switch down here, right? This one we're calling it a star. So Letabo has explained the disadvantages of the star. So the advantages will be, you see, it's easy to scale this network, right? Let's say now you want to plug in another device here because the switch is like maybe 24 ports, so it becomes easy for you to add other devices. So advantage number one, it's easy to scale up a star topology, right? Number two, it's easy to manage these / to troubleshoot this network. So if this device is the only net device that doesn't have internet access, and then all of these devices, they do have internet access. So that means now we have to focus only on what? On this one device. So it's easy for us to troubleshoot a star topology, right? We said number one is easy to scale it up. And then number three advantage is that it's easy to set up. This type of network is really easy to set up. You don't need many expertise to set up this type of network. So really easy to set up a star topology. And then do I have another advantage? Okay, it's fine. Now, the disadvantages will be maybe if this device fails, if you don't have any redundancy, and then the central device fails, then that means it affects your entire network. So when we're building our own networks, you want to see that we're going to be building something, building networks that have a bit of some redundancy. That if this switch fails, then the computers can use another switch and stuff like that, right? So that's the type of network that we're going to build, and then we're looking at different disadvantages and advantages of these networks here. Okay, so that's a star topology. Gabriela, what's the start? What is a ring topology? What do you know about a ring topology? So here's our ring topology.
So with the ring topology, I know it's located as a ring. That's how it looks. And if one device fails, then all devices fail. It's difficult to add a new device. So, am I right?
Yeah, like if you're trying to add a new device, then it affects the entire network. So it's not really difficult to add a new device, but it's just that it affects your entire network.
Yes, and one device communicates at one time.
Right. So a device only communicates when it has a token. So they listen and then wait for a token and then they start communicating. So now this type of design or this type of topology, it is okay for a smaller network. But if you're using a medium to large size network, the ring topology, it doesn't work. Like it will slow down your entire network. So people will be complaining about the internet speed, or maybe complaining that they can't send communication or they can't access certain things. So that's the problem with the ring topology, right? And then Matthew, what do you know about, or anyone wants to answer this one, the ring, the bus topology? So this is our bus topology. And then at the top there, that's our ring. And then this side, we say this is our star topology. Anyone, any advantages or disadvantages of the start of bus topology?
I know in a bus topology, before communication happens, there needs to be a waiting period that and signal might be lost.
Right. So, yeah, Humuso, you want to say something? Humuso? Your hand is, yeah?
Can you hear me?
Yeah, I can hear you.
Hello?
Yeah, I can hear you.
It requires less cable length.
Right. So it requires less cables, right? So that's the bus topology, right? So now, what's the other disadvantage? Anyone who wants to add any disadvantage to the bus topology? So again, guys, for those that are new when it comes to topologies, the topology we just said, it is the design, the way you design your network, right? The way you lay down your network. So that's the topology. So we said we have ring, we have star, we have bus, and then we're looking at the disadvantages, so that when you're planning on designing your own network, you're already making informed decision as to say, okay, you know that you can't build a network using a bus topology because these are the disadvantages and then these are the advantages. And then you can't use a ring, or you can use a ring because 1, 2, 3, or you can use a star topology because you fully understand what are the pros and cons of that type of network. So usually what happens is the client will come to you with requirements, right? They say, okay, I want you to build a network for me like this and that, right? Like they'll tell you, okay, I need a network with number of people, this number of people, and then I need to have this and that. The job requirements of these guys, this is what they're going to be doing, right? So now, because you fully understand how the design of the networks and then the topologies that we have out there, and then now you make a decision that will kind of like suit the company or the client's need, right? It won't affect your network. So if you're choosing a bus, you know, okay, if it's a bus, then that means now all these devices, when they want to communicate, before they communicate, they have to wait and listen on this line to see it, okay, is there any device that is communicating? So point number one, that it slows down your network, right? So the bus topology is slow, right? It slows down your network. And then if any device fails here, it affects your entire network. So that's the point number two. And then here on the end, if you don't terminate this end, it affects what? The entire network. The signal won't be able to travel on all of these networks. So the termination of this. So now these days, most companies, they go for, they go for star topology. Or there is another one called the mesh, right? The mesh topology, let me change this to blue. So let me close that. So what happens with the mesh topology? The mesh topology is a mix of all of the topologies. So you find, okay, maybe one area in your organization can do with the bus topology, and then you build maybe a bus topology there. And then maybe somewhere on the part of your network, you see that there's a ring, it needs a ring. Maybe you see it, okay, the other part of your organization, it will work fine with the star topology, then you design a star topology for that. So the mesh topology, it is a mix of all of these topologies. Does that make sense? Is that clear? What's the use of a mesh topology?
Yes.
Okay. All right. So let me move back to my slide and see if I can move out from the drawings. Sorry, I moved to the wrong slide. Where is my slide? Where is my slide? Okay, cool. I'm back now. All right, so topology diagrams, we have broken it down. What is a topology, right? And then when it comes to packet tracer, you will see we have two different types of topologies, right? We have the physical topology diagrams and then the logical topology diagrams. I will show you what does that mean on the packet tracer when we're going through packet tracer, right? I think some of you have showed you already, but we're gonna go through it together when we're doing packet tracer. Okay, common types of networks. All right, we have a small home office, and then so a small home like it's the one whereby we have maybe 2 people there, or maybe less than maybe 5 people on the network. That's a small network. And then the SOHO stands for small office, home office, right? These days, most people are working from home, or someone who has an organization, a company that is starting, right? It has less than 10 people or 10 computers in that network. So we call that network what? A small office, home office, right? We call it a SOHO. And then a medium or large network, these are like maybe advanced assessment or other big organizations like the banks, right? And then worldwide, this is where all of the internet is, right? All of the routers connect to. Okay, small home network connects a few computers to each other and the internet, right? So this is the type of setup that you have at home. Small office, home office enables computer within a home or remote office to connect to a corporate network, right? So home office, we're connecting maybe to a corporate network, that's a SOHO. And then medium to large networks, many locations with hundreds or thousands of interconnected computers, right? And then worldwide connects hundreds of millions of computers worldwide, such as the internet. So worldwide, here we're talking about the internet, where we have all of the people, all of the computers connected together. All right, now LANs and WAN. Network infrastructure vary greatly in terms of size of the area covered. So a LAN is found in one geographical location, and then it covers a smaller area. And then a LAN, it is like number of users, it has like few number of users, number and types of services available, area of responsibilities. So a LAN is easy to troubleshoot, it's easy to manage, unlike when we're using a WAN. WAN is really expensive to set up, and then it's kind of like really difficult to manage. All right. So there's that's the LAN, local area network, and then 2 most common types of networks is the LAN and the WAN. All right, size of the area. Okay, I think this makes sense. So anyone to explain the difference between a LAN and a WAN in their own words before I move to the next one? Anyone to? Anyone who wants to explain any difference between the two? Size of the area covered, number of users connected, number and types. Okay, you guys don't want to talk with me. Let me move to the next one. Okay, LANs and WAN continued. Okay, for today, let me stop here, right? We're going to continue tomorrow from where we left off. So we're going to go through. Okay, tomorrow we have web development, right? So tomorrow we're doing web development. So that means we're going to continue with this on Friday. So tomorrow we're doing web development. So make sure that you connect tomorrow if you're really interested in web development. The language that we're going to use is going to be CSS, JavaScript, and then HTML. All right, any questions, guys, before I close this meeting? Any questions before I close the meeting? Okay, T-Set, so you okay, Letabo?
So I was still waiting for the layer 3 part of the switch. I'm not sure if you explained it.
Layer 3 part of the switch. Let me see. So I did break it down, what it means there. Let me see. So the layer 3 switch, what we say what about that? We say the difference is that I did a drawing, right? And then on that drawing, there was like 4 computers, and then all of those 4 computers were connected to a switch, which is a layer 2 switch. And then I said, if it is a layer 2 switch, then those computers will be able to communicate within that network, right? But they won't be able to access the internet because the switch is a layer 2. So if I remove the layer 2 switch and then add a layer 3 switch, which is a multi-layer switch, now the devices will be able to access the internet and then also be able to interconnect within each other. So what the layer 3 switch does is it gives the capabilities. So the switch performs as a router and also as a switch, right? It has the routing capabilities, meaning that you can be able to access internet only with the layer 3 switch and then with the computer. So you won't need a router. So you find like these days, new networks, some people, they only buy a layer 3 switch, which that switch will work as what? As a switch, because it comes in with more ports, let's say 24 ports. Because usually back in the day, the routers, most of them, they have like maybe 4 ports, right? And then that 4 ports stands for 4 networks. But now the layer 3 switch, when it comes in with more ports, and then also it has the routing capability of taking one packet from one network to another network. That's the difference. That's what the layer 3 switch does. It breaks that limitation of a layer 2 switch, because we said the layer 2 switch, it only interconnect the devices and then allow those devices to be able to communicate, but those devices won't be able to access the internet or communicate with other LANs. But when we bring in a layer 3 switch, it has the capabilities of performing or working as a router. That's the difference only.
Okay, yes, you did explain.
Yeah, so yeah, that's it. And then on the packet tracer, I'm sure the 8.0, it has a layer 3 switch. So we're going to go through that and see how to configure a layer 3 switch. But the configurations are still the same. Right. All right. Let's see now. Any questions? Okay, I want to see who's on the group, who attended today. Artiseto, you've been quiet today. What did you learn today?
I learned the broadcast, the multicast, and the unicast of network, how they all functions. And then I also learned about the network media,
Okay.
the access of network through the medium, medium something. And then I also learned about the fire cables, how they are also used. Yeah.
Okay. All right. Thank you. Nantobego. Nantobego. What you've learned so far?
I've learned that there are different types of signal mode, which is multi and signal, which single is faster than all cables and multi is the signal bounces. And I've also learned the different advantages and disadvantages of wireless networks, which is the disadvantages are that they're unreliable, and as communication is done through open spaces, it's less secure.
Right.
Yeah, that's what I learned.
All right. Samulo, over to you. What have you learned so far?
Well, so far I've learned about network messages, where we have broadcast message, unicast message, and multicast message. Where in broadcast message, it goes to all devices. Unicast message, it is a one-to-one communication, and then multicast message, it is a single message sent to the group.
All right. Thank you. I'm just trying to check if like people were listening, you know. You guys can be quiet and then becomes lonely in here. All right, JJ, that's Pamanda, right? It's Pamanda Ndlele. Spa, what have you learned so far? JJ is Pamandla. I'm sure that's Pamandla then. Okay, Ellen, you can close it for us. Like, what have you learned in just a summary, and then we close.
I learned more about broadcasting, unicasting, multi, and the topologies because I wasn't there yesterday, so I'm just trying to settle in and understand what's going on. So, yeah.
All right. Okay, guys. Thank you all for joining this session. Tomorrow, make sure that you join. We're doing web development. How many people don't have laptops here? Because we're gonna need laptops for tomorrow. Because when we teach, like we need to play along, right? So Ellen doesn't have a laptop. Who else? Kindly, if you don't have a laptop, raise your virtual hand there. Okamo doesn't have a laptop. Tisetso, no laptop. Pindile, no laptop. Live there, no laptop. Amanda, no laptop. I don't know how we're gonna do this one. Because now on my side, on networking side, I'm just doing the breakdown of the theory side of the networking, right? But we will need laptops because you guys need to play along. Just what you call practice with us as we teach here. You know, you will need laptops, especially for web development. I don't know how we're gonna do this one. Okay, guys, make a plan. I think just use the whole stipend to buy a laptop, right? Even if it's a second-hand laptop, just for this training. I think the stipend is enough for you to get a new laptop, right? So just sacrifice for 1 month, since you are what you call you're not attending advanced assessment, you're always at home, so no transport money. Just divert the transport money or divert the stipend straight to a second-hand laptop. But the thing is, you'll see going forward as a technician, there's no way you can be a technician without your own personal laptop, right? It becomes difficult. So definitely, yes, you will need to have your own personal laptop. I know it's expensive. You don't have, for now, you don't have to get like a fancy laptop, right? You just need a laptop that will allow you to maybe practice or go along with us as we teach here. So you don't need a fancy laptop. All right, guys, I think for my side, I'm done. What you can do, drop your name, your surname there, and then the group that you are under, and then that's it. Thank you.
Pleasure, sir.
Thank you.
Bye.
Okay, sharp.
Sharp.
Hi. Yeah.
Thank you, madam.
Yeah. Hi.
Thank you. How do I type on this thing?
Yeah.
Type around. Type on young. I don't know.
Tisetso la le mathata eng? Tisetso la le mathata eng? Tisetso la le mathata eng? Tisetso. Ba G4S bone keng? G4S. Takatla ke mangwe la gae. Ke mangwe la gae. Yeah, man, the main thing is chaile, man. It's wrong.
To leave ke sa tlogela lebitso la ka. There is no way. Tshwanetse ba tsebe I was here.
Guys,
Sir,
did she said we must write our name and surname there?
yes,
Where?
by the what's this? The comment, what?
On the comments, they just drop in your name and surname, yeah.
Yeah.
And then
I can't see the comment
don't
box.
forget the group, right?
Yeah,
Don't forget the
I'm
group.
also don't see the comments. Where must I write my name and surname?
Press back. You don't. Manage to fight it.
Can anyone help with the comment box? I can't see it.
I also can't see it.
Esas da solile baba.
Mr. Moyo.
Yeah.
Mr. Moyo.
Uvayile lo muntu baba.
Lento le ayikho futhi lo comment andangazi fanda.
Pressa ubhek. Obvious ba press ubhek.
Sekhona bafo, sekhona,
Oh, sasekhona se.
Sasekhona, ngahamba.
Press.
Abheka. Usibhalisani ifoni noma i-laptop?
Ifoni.
Ifoni kwamele ibe phansi la i-option yakhona ithi bakudirect laba basibhalisa amafoni.
Press ubhek va.
Lapha nje kaziba uphuma lapha.
Yeah.
Yeah, pressa la.
Ngiyayibona no.
Tise tsona o sa gabe.
As I can't see it, please help me.
Who else does not see it?
I also don't see it.
On your phone, press the back button.
The back?
Yeah, like back button where you like previously go back.
Not the.
Yeah. Mfethu sibale ngipressile ubhek into angayibuyeli links.
Ayibuyeli kanjani mfana?
Yabona mayibuyela mfethu makumele utype mfethu ivele ntseki ipress usearch into angazi why imele isearch anta.
Obvious phela baceda ukupress iback izokisa kule nto le yama-chats angithi.
Ama-chat.
Yeah, le
chat.
yama-chat.
Game.
Kunala ngithi kumele upress chat khona la phansi.
Yeah, la ku-type message.
And then
nina nikuphi?
Kule back lesingena kayi asiyiboni thina.
Nama angiyiboni lento le.
Wena kama mfethu ifoni yakho ndanga yini inkinga yayo?
No, eyami baba iyayenza grand. Mina ngazi ezenu yini.
Wena tshela thi.
Ngicela ngibhalele mina. Ngibhalele.
Ukubhalela?
Yeah.
Ithuke masibhalele la.
Yeah,
Phindile.
Ima ngizonibhalela.
Yeah, sibhalele.
Ekamu.
Isicelo ngosandile.
Sibhalele sonke.
Sandile, obvious.
Phindile.
Utheni kunophindile.
Josias.
Josias.
Hey baba.
Yeah.
Hey. Isezo kwena apho mu.
Yeah.
Ekabo sobhalila ngithi.
Ya wena sengikubhalile ungaphuma mkhozi.
Kamu. Nami songibhalile lapha.
Okay, phindile Sandile senginibhalile.
Isethu.
Okay, nithi ngibhale writings. Oh.
Josias.
Ya ima Josias.
Okay.
Ngibhala wena no.
Okay.
Kamuskantibala.
Matisetso. Okay, Josias ngiqedile.
Okay, thank you.
Isetso. Ke feditse. Then the other one. Omunye futhi. Ngakekho. Wala bethu everything.